Saturn, the Lord of the Rings, a gas giant crowned with dazzling rings, captivating us for centuries. But NASA's Cassini mission shattered our old ideas. For 13 years, Cassini orbited Saturn, sending back data that transformed our understanding. This wasn't a quick flyby. It was a deep dive into Saturn's mysteries. Cassini captured nearly 500,000 images, revealing the planet's dynamic, ever-changing nature. It even sent the Huygens probe to Titan, landing on a world shrouded in orange haze. Cassini showed us a Saturn alive with storms, shifting rings, and strange moons. Today, we'll uncover 5 mind-blowing truths from Cassini's discoveries. No myths, just science. Let's dive in. Saturn's rings look eternal, like shimmering jewels encircling the planet, a cosmic crown that has fascinated skywatchers for centuries. Their icy brilliance has inspired countless myths and scientific curiosity, making Saturn one of the most iconic sights in our solar system. But Cassini, the intrepid spacecraft that spent over a decade exploring Saturn, revealed a startling truth. These magnificent rings are vanishing before our eyes. What once seemed permanent is, in fact, fleeting. The rings are raining down onto Saturn, a phenomenon scientists call ring rain. This isn't just a gentle drizzle, it's a relentless downpour of icy particles, constantly pulled by Saturn's gravity. Every single second, hundreds of kilograms of these icy particles spiral into the planet, lost forever to its vast atmosphere. Imagine a never-ending snowfall, but instead of snow, it's the very material of Saturn's rings dissolving away. At this astonishing rate, the rings could disappear in just 300 million years, a mere blink in cosmic time, especially when compared to the age of the solar system, which stretches over 4.5 billion years. We're incredibly lucky to witness Saturn's rings at their most brilliant during this brief window in history. For most of the universe's existence, Saturn has either been bare or will be bare again. Cassini's data suggests the rings are surprisingly young, possibly forming just 100 to 200 million years ago when dinosaurs still roamed the Earth. Imagine a T-Rex looking up at a newly crowned Saturn. These rings likely didn't form with Saturn itself. Instead, they probably came from a moon or comet that ventured too close, torn apart by Saturn's immense gravity. The shattered remains spread out, creating the dazzling rings we see today. If you could travel back to the age of the earliest dinosaurs, you might have seen a ringless Saturn, just another gas giant, unadorned and unremarkable in the night sky. And in the far future, Saturn will return to that bare state. Its rings will fade away, leaving only faint traces for distant civilizations to wonder about. The rings are a fleeting spectacle, a cosmic hourglass marking the passage of time, reminding us that even the grandest wonders are temporary. As the icy rain falls, it doesn't just vanish. It mixes into Saturn's atmosphere, subtly changing its chemistry and possibly even its color over millennia. The planet and its rings are locked in a slow, transformative embrace. The rings aren't just decoration. They interact with Saturn in a complex gravitational dance. Waves ripple through the rings, and Saturn's magnetic field shapes their structure, creating a dynamic system that's always in motion. Cassini showed us that Saturn is a world in flux, not a static painting. Its appearance is always changing, shaped by forces both seen and unseen. The beauty we see is temporary, a fleeting masterpiece painted across the sky for a short time. So next time you spot Saturn's rings through a telescope or in a photograph, remember, you're witnessing a rare and precious moment in the planet's long, dramatic story. The Lord of the Rings is abdicating its throne, and we're here for the final act. A cosmic drama unfolding before our very eyes. Earth's storms are nothing compared to Saturn's fury. In 2010, Cassini witnessed a storm so massive it could swallow our planet whole. This great white spot wrapped around Saturn, stretching 20,000 kilometers, twice Earth's diameter. Lightning flashed with 10,000 times the power of Earth's, and winds howled at over 500 km/h. The storm dredged up material from deep within Saturn, revealing its hidden depths. For 200 days this vortex raged, leaving scars in the atmosphere. What drives it? Moist convection. Like Earth's thunderstorms, but supercharged. Ammonia ice clouds towered 100 kilometers high, creating a blinding white spectacle. These storms vent Saturn's internal heat, resetting its atmospheric clock. Cassini's long-term watch gave us the first complete view of this epic event. The storm left behind warm vortices, beacons, that lingered for years. Saturn's calm face hides a violent, ever-changing world. Cassini and Huygens took us to Titan, Saturn's largest moon, a world both familiar and alien. Orbiting in the cold, distant reaches of the solar system, Titan is shrouded in a thick orange haze, hiding its secrets beneath swirling clouds. For centuries, astronomers wondered what lay beneath that mysterious veil, and it wasn't until the arrival of these robotic explorers that we finally caught a glimpse of Titan's true nature. In 2005, the Huygens probe made a daring descent through Titan's dense atmosphere, parachuting down for hours before finally touching the surface. As it fell, it captured images of vast river channels, winding shorelines, and a landscape eerily reminiscent of Earth's, yet shaped by a very different kind of liquid. But here, the rain isn't water, it's methane and ethane, hydrocarbons that are gases on Earth but flow as liquid in Titan's frigid environment. These alien rains fall from thick, dark clouds, carving rivers and filling lakes in a cycle that mirrors our own water cycle, but with chemistry utterly foreign to us. Titan's lakes and seas, mapped in exquisite detail by Cassini's radar, are filled not with water, but with liquid methane and ethane. These vast, dark bodies of liquid collect in craters and basins, forming a landscape that is both alien and strangely familiar. The largest of these seas, Kraken Mare, is so immense that it dwarfs all of Earth's Great Lakes combined. Imagine a sea of liquid methane, hundreds of kilometers across, stretching into the orange haze, an ocean on another world. Cassini even caught sunlight glinting off these alien seas, a fleeting reflection that proved these lakes were truly liquid. For a moment, the sunlight traveled 1 billion miles to dance on the surface of a world so cold, so distant, and yet so dynamic. Titan has a full methanological cycle: evaporation, clouds, rain, rivers, and lakes, all powered by the faint warmth of the distant sun. It's a complete system, echoing Earth's hydrology, but with methane and ethane taking the place of water. Cassini watched as clouds gathered and drifted across Titan's sky. Rain fell in sudden storms, and shorelines shifted with the seasons. Even from 1 billion miles away, we could see the signs of weather, change, and time on this distant moon. Titan's thick, nitrogen-rich atmosphere is 4 times denser than Earth's, creating a world where the sky glows orange and the surface is cloaked in perpetual twilight. This dense air slows falling raindrops and muffles sound, making Titan's environment even more otherworldly. If you stood on Titan, you'd feel the weight of your spacesuit, but with wings strapped to your arms, you could almost fly, leaping and gliding through the thick air and low gravity, soaring gently above the frozen ground. When Huygens landed, it touched down in a dry riverbed, surrounded by pebbles of water ice, hard as rock in Titan's deep freeze, shaped and smoothed by ancient methane currents. The landscape told a story of flowing rivers and changing climates. Where there's liquid, energy, and organic molecules, there's potential for life, just not as we know it. Titan's chemistry is exotic, but it raises the tantalizing possibility that life could arise in forms utterly unlike anything on Earth. Titan is a natural laboratory for exploring the boundaries of life itself, a place where the familiar and the alien meet, and where the next great discovery may be waiting beneath the orange clouds. Saturn's North Pole holds a mystery that has fascinated astronomers for decades, a perfect six-sided storm known as the hexagon. Unlike anything seen elsewhere in our solar system, this geometric weather pattern is both beautiful and perplexing, defying easy explanation and sparking curiosity since its discovery. First glimpsed by the Voyager spacecraft in the early 1980s, the hexagon's true scale was only revealed decades later by Cassini. Stretching an astonishing 30,000 kilometers across, this massive structure is so large that you could fit 4 entire Earths inside its boundaries. It's a storm system on a scale that's almost impossible to imagine from our perspective here on Earth. The hexagon isn't a feature carved into Saturn's surface. It's a stable, rotating weather pattern suspended high above the planet's clouds. It moves independently of the planet's deeper layers, maintaining its shape year after year, as if drawn by some invisible hand. At the very center of this hexagon lies a massive polar hurricane, with winds swirling at hundreds of kilometers per hour. This storm is so intense that its eye is larger than most hurricanes on Earth, and it has raged for as long as we've been able to observe it. The hexagon's sides are remarkably sharp and well-defined, rotating almost perfectly in sync with Saturn's day, which lasts about 10.5 hours. This synchronization adds to the mystery, as the pattern seems to be locked to the planet's rotation in a way that scientists are still working to fully understand. So how does such a precise shape form in the chaos of Saturn's atmosphere? Cassini's data revealed that the hexagon is actually a standing wave, created by a powerful eastward jet stream. Unique atmospheric conditions on Saturn cause this jet to buckle and fold, locking it into a six-sided shape that remains stable over time. To test this idea, scientists recreated the phenomenon in the laboratory. By spinning fluids at different speeds in a dish, they were able to generate polygons, including hexagons, proving that such shapes can arise naturally from the physics of rotating fluids. This experiment helped confirm that Saturn's hexagon is not a fluke, but a natural outcome of the planet's unique conditions. One of the most striking features of the hexagon is its ability to change color with Saturn's seasons. During the long Saturnian winter, the hexagon appears blue, but as spring and summer arrive, it shifts to a golden hue. This transformation is caused by sunlight triggering complex chemical reactions within the storm's boundaries, altering the composition and color of the clouds. The hexagon also acts as a kind of atmospheric fence, sharply separating the air inside from the air outside. This barrier is so effective that it creates its own isolated climate, with distinct weather and chemistry, almost like a continent floating in Saturn's sky. Saturn's hexagon is a self-contained, continent-sized weather system, one of the solar system's strangest and most enduring wonders. Its perfect geometry, immense scale, and mysterious origins continue to challenge our understanding of planetary science, reminding us how much there is still to discover in the universe. How long is a day on Saturn? For gas giants, it's a tough question. No solid surface, just swirling clouds. Voyager measured Saturn's day by its magnetic field, 10 hours, 39 minutes, but Cassini found the radio signals changed, even between hemispheres. The planet's true rotation was hidden. The answer came from the rings. Saturn's interior vibrations create gravity waves that ripple through the rings, leaving subtle patterns. Cassini mapped these waves, using the rings as a giant seismograph. The result: Saturn's true day is 10 hours, 33 minutes, 38 seconds, 6 minutes shorter than we thought. This discovery reshaped our models of Saturn's interior. Cassini's final act was a selfless one. To avoid contaminating Titan or Enceladus, it plunged into Saturn's atmosphere in 2017, ending its mission with a final sacrifice. For 13 years, Cassini was our eyes in the Saturnian system. It revealed a world more dynamic and beautiful than we imagined. From vanishing rings to alien seas, Cassini rewrote the book on Saturn. With its fuel gone, Cassini's final act was to protect the moons, ending as a meteor in Saturn's sky. Its last signal reached Earth on September 15, 2017. Cassini's legacy is a treasure trove